Hi guys, in my previous lecture I explained to you the structure and functioning of the heart, and now in this lecture I have picked a very appropriate question from the past papers and I'm going to be explaining the question along with the marking scheme. So let's do the question. Figure 2.1 is a diagram of a vertical section through a healthy mammalian heart. Label two chambers of the heart by writing in the boxes provided on figure 2.1. So I have this in this box. Now, as I explained, the upper two chambers are called the atria and the lower two are called the ventricles. Because this is the right one, so this is the right atria, and because this is the lower one and it's on the left, so this is the left ventricle, right? So this is the right atria and this is the left ventricle. Okay, so coming to question number 2. State two ways in which the composition of blood entering the right atrium is different to blood entering the left atrium. Okay, so this is also a very simple question. So you know that the right atrium, it receives blood from the vena cava, the inferior vena cava and the superior vena cava, whereas the left atrium, it receives blood from the pulmonary artery. The vena cava has deoxygenated blood, and the pulmonary artery, because it enters the left atrium after the blood travels through the lungs, so it has oxygenated blood. So the blood in the right atrium, the first difference, the blood in the right atrium has less oxygen, and the blood in the left atrium has more oxygen. So this difference in the oxygen concentration is one difference. Now coming to the second difference. Now, because this is deoxygenated blood, so the blood in the right atria has more carbon dioxide. But once it passes through the lungs and then enters the left ventricle through the pulmonary artery, it has been oxygenated. The carbon dioxide has diffused out, so it has less carbon dioxide. So this is the second difference. What? The right atria has more carbon dioxide, the left atria has less carbon dioxide. There is another difference as well, and that is the blood in the right atria has more water content. Why is that so? That's because once the blood enters the lungs, what happens is that some of the water diffuses out, right? And hence there's less moisture when the blood returns to the left ventricle after passing through the lungs. So we have done this question as well. We'll move on to the next part. Some people are born with structural defects of the heart and its associated blood vessels. This is known as congenital heart disease. The dotted circles labeled A to G on figure 2.2 show some areas that are affected by different areas of congenital heart disease. The structural defects causing 4 types of congenital heart disease are described below, so I'll come to them later. Match the one correct area from A to G on figure 2.2 with each of the congenital heart diseases. The first one has been completed for you, so I'll talk about the rest. Pulmonary stenosis. So here they say pulmonary stenosis, a narrowing of the semilunar valve of the pulmonary artery. So we need to identify which of these is that. So first we will identify which one is the pulmonary artery. The pulmonary artery, as you can see, is this one, right? I told you arteries are the blood vessels which transport blood away from the heart. So the pulmonary artery, it transports blood from the right ventricle. It travels here and then to the lungs. So this part, G part, what has happened is that this part has become narrow, right? And we have identified the location. So this disease corresponds to G. Okay. The second problem is coarctation of the aorta, a localized narrowing of the aorta. We need to identify where the aorta is. The aorta starts from here and then continues all the way down here. So here you can see that the aorta has become restricted.